in opposite side. If we put this with these two circles in motion, we will have something that solves the entire problems we have with Ptolemaic model. And this is this. Look at this point. With a combination of two circular motions, we create a linear motion. This point is moving in a linear way. What was the importance of this? The planet is moving ahead. By applying one of these, I can bring it closer to me. When it is closer, and I want to put it a little further to keep my centrality, I can move it a little back. Before 2C, nobody were thinking about nobody. We don't have any evidence that people thinking about this in one. Okay, then 2C applied it in different models he created for Mercury, for the Moon, and other planets. And after the fall of the Meral Observatory, these ideas spread in all Persia, in the west and in the east and the west. And we see that new models were created. One of the most successful model developed by Ibn Shatir almost 100 years after 2C in Damascus. He created this model for Mercury. And this is another model in Bukhara, eastern part of Iran, in Uzbekistan. He made using Sahib Tazkira, he talks about 2C here, and the same thing here. He developed a new model based on 2C's couple. And then in 1420s, a new observatory, which was the largest observatory in pre-modern era in the entire world, was established in Samarkand by Ulugh Beg, and he put a lot of money there. And Samarkand School and Observatory was the largest institute, educational institute in pre-modern world. We have documents that at that time, in Ulugh Beg's time, there were 10,000 students studying in Samarkand. 10,000. 500 of them were mathematics students, mathematics and astronomy students. There, Ulugh Beg was a mathematician and astronomer, and then Jamshid Kashani and Qadizadeh Rumi and Ali Kushi. They made the largest observatory in the world at the time. This is the quadrant that they used. It's the largest one ever built. And there also, they worked on this theoretical astronomy. Basically, Ali Kushi developed a lot of, in fact, two new models based on 2C's couple. And this was the picture of that time. We see that before 1450s, before the fall of Samarkand Observatory, a lot of students traveled from western parts of Islamic world to go to Samarkand, to Bukhara, Herat, Merv, to study there. As I said, before that, Maragha was the Harvard, and then they moved to Samarkand. And many, many students traveling there to study there. And we have some documents that I don't know from where, but he says that we had a delegation from Farang, which means Europe, somewhere from. They sent a few mirrors there to ask scientific questions about these mirrors. That was so well known, the Samarkand Observatory. People asking scientists there to solve their problems. But after the fall of Samaria Lugbek dynasty, they traveled. In fact, a big immigration started. All scholars travel because there's no patronage there. They traveled to Ottoman Empire, which was a growing state. They had a lot of money, building new educational centers, and also to India. And this immigration speeded up after the rise of Safavids, which they forced people to change to convert their religion, and obviously changing religion for a peasant was very easy to do that, but most famous scholars, which were mostly Sunni, they were not so, that was not so easy for them to change their religion, so they escaped and they moved to Ottoman Empire, which was a Sunni state, and helping supporting these efforts. And then what happened? Let's jump 400 years. In 1893, for the first time, Bernard Cardevaux translated the part of Tusi's Tazkira. And that was, he translated it for Paul Tannery's astronomy, which was the big source, major source about the story of astronomy. There he translated Tusi's couple and the new model of Tusi, but he didn't really realize the importance of this new discovery. He thought that these astronomers were not so faithful to Ptolemy and they didn't understand Ptolemy, but he himself didn't realize the importance of this discovery. In 1957, Otto Neugebauer discovered that Ibn Shader's model, Ibn Shader used Tusi's couple to develop a theory of, in fact, the new models of planetary motions. He discovered that Ibn Shader's model is exactly the same as Copernicus' model. It was so obvious that Neugebauer didn't know Arabic. He put just the drawings and he compared the drawings. He found that these are identical. Then Edward Kennedy, he was in Iran during World War II. Then he was a professor at Beirut University, American University of Beirut. He studied, he knew Persian, Arabic, and astronomy, mathematician. And for the first time, he published about Ibn Shader's model as a pre-Copernican model. It was before Copernicus, but exactly the same as Copernicus. Then, in 1973, a major discovery happened, and Billy Hartner discovered that the proof of a theorem in Copernicus' work carried the same alphabetic designators for geometric points as they had appeared in Tusi's work. After that, a lot of people, Kennedy, Saliba, Raja, Abdallah, and others, worked on Copernican models and the possible contact routes or contacts between Copernicus and other astronomers in the eastern part of the world. Here is the model developed by Ibn Shader and Copernicus. They are identical, the same, using Tusi's couple here. Here is Copernicus drawing, and this is Tusi's. This is Aleph, this is Aleph here. He didn't continue in Latin sequence of alphabet, A, B, C, D, E, F. He continued Abjad, Abbas, Utti, as A, B. So it is A, this is J here, G here, H is Ha here, and so on, so on. Willy Hartner confused a little, and he thought that there is a discrepancy between 2C